All right, so welcome back to our training day with Xamarin. And we're going to actually talk about something that I think is really, really important, which is profiling your application. It sort of falls in the area of debugging your application, but it's something that a lot of developers don't take the time or perhaps don't have the knowledge to do. And so we're going to talk about how to analyze your applications using a profiler so that you can identify problems in those applications before you deploy them to your users.
And I'm really excited to see this because I'll be honest, I'm one of those developers that doesn't use this tool anywhere near enough. So,
all right, so we should start by introducing ourselves.
I think so.
My name is Mark Smith. I'm the director of Xamarin University, so I'm responsible for curriculum and training and just generally the feel of Xamarin University itself.
Fantastic. And my name is Adrian Stevens, and I'm the curriculum lead for Xamarin University, and that means that I work with the very talented people that create the training materials for Xamarin U. So it includes the live training and as well as the online self-guided learning portal that we have.
Which I hear great things about.
Fantastic. Yeah, we love it. We're very proud of it, and we'll tell you more about that a little later on.
Awesome. So we should probably tell you what Xamarin University is. Xamarin University is an online training center that you can come to in order to learn how to be a mobile developer.
Cross-platform mobile developer.
Cross-platform mobile developer. There's lots of different pieces to it.
Absolutely there are. So we've got live instructor-led training, and this is really the premium experience of XAMU. This is the place to go learn cross-platform Xamarin Mobile development. We have expert instructors that teach classes live over a huge range of topics, everything from getting you started with Xamarin Forums all the way up to really advanced topics like memory management and even some profiling.
That's right.
As well, we've got a thriving community. We've got forums, so you can engage with other students as well as the instructors. And one of my favorite features, you can schedule one-on-ones. So with your favorite instructor, or really an instructor that has expertise on a specific topic, you can ask them about really anything Xamarin related.
Right, so does that include things like, I want to use this feature in my app?
Absolutely. Ask about embedding features into your applications, maybe even debugging. Maybe you need a hand profiling your application.
Awesome.
And of course, there's the Xamarin certification.
Right, which Xamarin certification lets you go through a series of classes and some homework assignments and some check-ins with instructors where you get to meet with office hours, and then finally a final exam. And once you get through that entire program, you are a Xamarin certified mobile developer, which gives you access to lots of great benefits, but most importantly, sort of just indicates to the world that you know what you're doing.
Right. You show everyone that you know how to build cross-platform mobile Xamarin applications.
Right, and if you want to learn more, you can go to university.xamarin.com and check out all the different courses that are there. There's a bunch of free training that's there, including our self-guided system.
Right, absolutely.
Right, that you can go through. You can try out some of the live classes with our instructors and just generally see what it's all about.
Absolutely.
Great. Well, one of the things we want to make sure that you get a chance to do as well is to ask your own questions. And so make sure that as you're kind of going through this, you can ask questions during the event, or you can even go to university.xamarin.com, and there's a place where you can contact Xamarin University as well, or you can go to the forums.
Absolutely, lots of places to get your questions answered. But yeah, use the features here today. Use the QA features. We've got experts on hand ready to answer your questions.
Right, that's exactly right. So let's go ahead and get started and talk
Excellent.
about profiling. So one of the things that we need to first start with is to kind of level set sort of where we are and to remind ourselves exactly how things are structured when we build a mobile app. Now, I want to be clear here. Some of the things that we're talking about here, we're going to focus on Xamarin development, which is all about cross-platform mobile development. But a lot of these concepts actually apply to any sort of application that you might build. So it doesn't matter if you're a web developer or a desktop developer doing WPF or Windows Forms even, you can benefit from the knowledge of how to use a profiler. And one of the things that we have to understand straight out, Adrian, is how memory is organized in our .NET applications.
Absolutely, because it differs from perhaps a native application or an application written with the native languages.
That's right. So, for instance, I'm an older developer, and so I started my career back when it was just C and C++. And in C and C++, there are direct functions that you call to allocate a block of memory, and you tell it how big you want it to be, and then to deallocate that memory.
Right, I remember those days of forgetting to deallocate and free up that memory.
That's right, it's very common to have problems in our apps where we would run out of resources because we forgot to deallocate the blocks.
Right, and the burden's placed on the developer to manage that.
That's right. In .NET, we don't have to actually generally deal with that because we have a garbage collector. And the garbage collector is responsible for coming up behind you and periodically freeing the memory that you're no longer using.
kind of something pick up after you.
Yeah, kind of. It's kind of like, you're sitting at a fancy restaurant and you're eating your dinner and you turn around to have a conversation with your friend and you look back and your plate's gone. That's the garbage collector, right? It came and it took your plate because you were finished, right? And that's basically how it works in .NET as well. And we have the same thing when we run our mobile apps in iOS or in Android. Now, when we define actually memory itself, that's another area that we kind of have to make clear.
Right.
So we have our process, that's where our application code runs. And in that process, we have memory where we get native things allocated. So in iOS and Android, like give me some examples of native objects.
It could be images,
Right, images, sure.
controls,
Yep, controls.
scarce resources, maybe file handles.
Sure, exactly. And these things are things that we're allocating from the operating system itself or perhaps from a framework that was included by the vendor. So for instance, you mentioned controls. That's a great example. We never want to forget that when you use Xamarin, you're actually using the native controls of the platform. So when we, for instance, create a text box in our technology, we're actually going to be leveraging a UI text field or a UI label or
the native
a text
control.
view in Android. So something that's native to the platform. And those things are going to be allocated out of the memory space of the process itself. But we have a second type of memory when we're actually dealing with .NET or with Xamarin
Okay, that's
applications.
interesting.
And this secondary memory is our managed memory. This is the area that's actually going to be cleaned up by the garbage collector. So this is the stuff that we allocate, say, in C#.
Okay. But we're allocating our controls in C#. So would that not go in the managed memory space?
Well, it kind of does. That's a great question. We have two different things that are really being allocated here. We've got the typical sort of C#.NET objects that are completely managed and they live completely isolated in that managed memory block. But then we have some things that kind of live in both worlds.
Okay.
Right? Where I have a representation both in the native world, say a control or a visualization of some kind, and then I have a portion of that that actually exists in the managed world as well. And these are actually a little bit harder to clean up. When it's just managed stuff that sits solely in that managed block, the garbage collector has no problem coming through, figuring out, hey, are you still in use? No, I can throw you away.
Right, that's all taken care of for us.
That's all taken care of for
Generally.
us. Yeah, we don't have to worry about it. But when it comes to these visual controls, say things that perhaps live in both worlds, it's a little harder because we can't get rid of it until both sides are done. My managed code or my C# code that's running has to be finished using the object, and the native platform has to be finished using the object as well before we can actually clean it up.
Now, this sounds complicated. Is this something we have to worry about all the time in applications? Are you managing memory on both sides?
It's horrendously complicated, but luckily, the Xamarin Framework takes care of all of that for you.
Fantastic.
So the runtime is going to do a lot of the work. But there are some places where we can actually run into trouble, and that's where our profiler is actually going to help us to identify some of those problems.
Excellent.
So typically speaking, when we talk about memory in the managed world and we talk about memory leaks, we're really sort of referring to a different problem than we had with the C and C++ world, because we no longer have a free or a deallocate API. Instead, we're going to let the garbage collector do the work, but sometimes the garbage collector kind of fumbles the ball a little bit. It can't quite figure out when it should get rid of this memory. And there's some specific scenarios where that happens. One of the most common, Adrian, is when an object is being held onto in memory. We call this a reference or a live reference.
Okay.
And so this is when, say for instance, I create an object, I allocate object A, and I insert that into a list, and I still have a hold of the list. I let go of my reference of object A, but because it's still inside this list, it has to be kept alive.
And so we call it a live reference, right?
That's correct. We call it a live reference. And so anytime that we actually take a live reference, whether by our application code or by the framework of some kind, we pass it into some API, that object is going to be kept alive, and the garbage collector can't collect it.
Okay, so we're really preventing that managed memory from being freed or cleaned up.
That's exactly right. And so it's just going to live until we get rid of those references, and then the GC can come along and collect it. Another thing that sometimes happens, this is a little less rare, the first case of holding on to references is by far the most common way to leak memory in the managed world.
Right, we almost saw it as a .NET memory leak.
Yeah, that's exactly right. That's almost the classification we'd use.
Yeah.
Another way we can actually sort of hold on to memory unintentionally is through thread local variables.
Okay.
All right, so this is where we actually allocate a variable that's specific to a thread, right? It's where the thread itself, right, there's some special C# syntax that we can use to do this. There's some attributes you can use, or you can use specific keywords and APIs to be able to manage this. But the idea is that each thread gets its own unique local copy of that particular value. And so each thread can have a different value for that variable.
And that sounds like a very powerful thing to do when threading, so we're not competing for the same memory.
Exactly, and actually it's a great performance thing, because often we don't want to share those values, because that then begins to provide contention across those values. But the downside is in order to implement this, they have to kind of hold references to things, and so it can be unintentional if we don't clear that value out. We might actually hold on to it unexpectedly.
And so the thread is keeping the object alive in memory.
That's exactly right. So the third way we can do it is where we pass the object into the native world. All right, so say for instance we allocate something and we then pass it into an API that exists in iOS or in Android or even UWP or WPF. All of those systems have native representations for UI that are being held onto, and if we pass those references in, sometimes those references have to be held onto by the native platform too.
Which makes sense, because of course we're interacting with those native APIs on the native platform.
Exactly. We call this pinning the objects because they're actually locked in memory as well. And this has a couple of other ramifications, but for our purposes, all we really care about is we can't free it, right? And so we want to be able to identify those particular scenarios and make sure that we clean them up appropriately.
All right, I'm excited.
But memory is not the only thing we often have to think about, Adrian. We also have to think about CPU utilization.
Ah, yes, very important, especially on small devices.
That's right. So when we're dealing with mobile devices, such as our phones or our tablets, we don't really have exactly the same sort of processor capabilities that we do on, say, our laptops or even our desktop or server machines.
Now, I mean, I've got a pretty fancy smartphone. It's pretty powerful.
They are. You're absolutely right. In fact, if you actually look at smartphones today, they are by far more powerful than the computers that we used, say, even 10 years ago. But even still, they are small devices. They have limited processing capabilities, and we need to keep that in mind as we write our code.
And probably limited battery life as well.
Yeah, that's right. Yeah, and actually that's a great point, Adrian. You know, the more CPU you use, the more battery life you're going to use. And I can guarantee you that today, anyway, on Android and iOS and Windows Phone, you can actually go and look and say, who's the biggest offender for my battery usage?
Yes, absolutely.
And I can guarantee I can tell you who's going to be the first app they uninstall. Right? So we want to be careful and not necessarily consume all the battery life. Now, one way that we can mitigate this, Adrian, is to kind of push things off of the mobile device itself. So, like, tell me, I know that you've done a lot of mobile development. Like, what sorts of things have you done to kind of deal with long calculations or things that were tangibly more CPU oriented?
Absolutely. I mean, my guidance is always, if you can avoid it, don't do it on the device.
Yeah.
We've got fantastic cloud infrastructure. Azure obviously is very powerful, really easy to integrate with our mobile applications, especially from a Xamarin point of view. And so if we've got some heavy lifting to do, I like to push that off to a service.
Right.
Something on Azure, have it do the crunching, and we can just interact with that via probably a REST API.
Yeah. Yeah, that makes total sense. So where we can, try to push it off. And where we can't, we just need to sort of be more conscious of this. And in particular, think about the architecture of your application itself. And so, Adrian, I know that you've done a lot of mobile development. Have you ever had a case where you're using a mobile app and then suddenly it just kind of stops for a second or freezes and then sort of comes back?
Well, maybe once or twice. Yeah, it definitely happens.
Not your apps.
Well, never mind.
That's right.
No, absolutely, we see that all the time, and it's not a pleasant user experience. We talk about it. We buy these fancy phones.
Right.
We expect them to be fast. We expect them to be responsive, and when that doesn't happen, it leaves a bit of a bad taste in our mouths.
Yeah, absolutely. Well, we want to make sure our applications are responsive, or what we used to call fluid, right?
Yes.
Fluid and responsive. And so it's helpful to understand exactly what our architecture is when we deal with a mobile app. And this is true, by the way, for most UI platforms. So even if you're dealing with UWP or WPF, the desktop world, this is going to be the same there as well. The idea is we have a thread, right? A thread is just a point of execution that's executing our code. And that thread is really responsible for dealing with all of the UI events. And so as we interact with the device, that thread is then kind of processing those things. And it makes calls into the native operating system, as you can see here, which could be Android, iOS, or Windows. The operating system then feeds back events, things like the user touched here, the user swiped there, the user did a gesture, the user, some notification came into the phone, those sorts of things. Those events are then correlated and put into a queue, and that queue is read by that UI thread.
Right, and we call it the UI thread because it not just displays UI, but it's all the user interaction, right?
Exactly.
It's the in and the out for the
That's
user.
exactly right. So events that are coming from the device related to user events or perhaps notifications or things like that come in on that thread as well. And the important thing to remember about that thread is that you do not want to stop processing events, right? Because when you stop doing UI things on that thread, when you stop actually receiving those system events and processing them in a timely fashion, what happens?
Well, your app stops.
Yeah, that's right. That's exactly right. You end up with stuttering kind of apps. And so we want to make sure not to have that happen. And so we don't want to, for example, do file I/O on the UI thread. We want to make sure to stay off the main thread when we're doing anything that's intrinsically blocking.
That's not usually expensive from a CPU point of view, though, right? It doesn't take a lot of processing
No,
power.
absolutely not. But the problem is when we do file I/O, the thread that's doing the I/O itself has to stop and wait for the data to come in from whatever it is. So for instance, if I'm doing database calls, I'm doing a query, and something is going to then queue up some sort of I/O on the device, or perhaps it goes to the cloud, right? Maybe it's a web service call or something like that, and I'm going to have to wait for the data. That wait might be really small, in which case maybe it's not even noticeable when I'm using my app, but maybe it's not. Maybe it actually takes a little bit of time to process that particular I/O request, in which case my thread's just waiting for the data, and it's not doing what it should be doing, which is processing those UI events.
That makes perfect sense. And I guess especially with things like network calls, we don't really know how long it's going to take.
That's
so
exactly right,
it's
yeah.
inconsistent.
Yeah, that's exactly right. So things like network calls, things like doing CPU-intensive calculations, we want to go ahead and make sure that either those don't happen on the UI thread so that we don't block that thread, or maybe we even want to push those into the cloud, as Adrian said earlier.
All right, well, it sounds really easy, but...
It is, Adrian, it totally is. Right, so there's
yeah.
lots of different ways that we can actually identify these sorts of problems. One of the things that we can do is we can use a tool. And there are several vendor tools available. So Apple has Instruments, which is an Apple-based tool that comes with Xcode. You can run that on your native iOS or Mac applications and get a sense of where is it spending its time, how's it allocating its memory. Android has a similar tool. It's called Android Device Monitor. You can take heap snapshots and kind of see memory allocation patterns and force GCs to occur on the Android device. We've got a Mono-based tool called HeapShot. It's an older kind of tool that's free that you can download and use that'll let you kind of monitor heap allocations. And then we've got two tools that we're actually going to sort of focus on today. One is the Xamarin Profiler. The Xamarin Profiler is a tool that's specifically intended to profile iOS and Android applications when you're using Xamarin's cross-platform.
Okay, so I would use this if I'm doing cross-platform, but I might use the native tools if I was just targeting one platform?
You might, and sometimes it's actually good to mix them as well. Like I might choose to use one of the native tools to get a sense of the native side,
okay.
Right? Because the Xamarin Profiler is really going to give me a better insight into the managed allocations and sort of what's happening. I can see the native call stack as well, but I might get a little more detail if I use a vendor
Oh, so
tool.
it's even different information with the different tools as well?
Yeah, it
okay.
could be. And then, of course, we have the Visual Studio Profiler. So in Visual Studio 2017, there's a built-in profiler that you can use. I think it's Enterprise Edition.
Right,
but
yes.
once you have Enterprise Edition, you can actually use the Visual Studio Profiler, and it will let you profile web apps, desktop apps. In fact, the debugger itself will even give you some of that detail when you run. You might have noticed a diagnostic window often comes up in the
Yes,
debugger.
you very often see it come up, and it's there by default on your UWP applications.
That's exactly right. And so you can watch CPU allocations, you can watch memory allocations, and get a sense of where your app is. But we're going to kind of focus on the Xamarin Profiler here. These profilers both come with Visual Studio, and they're actually installable through the Visual Studio installer.
Oh, that's fantastic.
And both of them, by the way, require the Enterprise Edition of Visual Studio. So you have to have an Enterprise Edition of Visual Studio to actually install these and use both of these tools.
Okay.
Now, the Xamarin Profiler itself is also available on the Mac. We're going to be looking at it primarily on Windows today, but be aware that you can actually run it on the Mac as well. It's a separate download. It can be installed through the Xamarin installer, or you can actually go to our docs page and kind of read a little bit about the profiler as well as download the latest
Okay,
release.
fantastic. And again, this kind of goes back to our ability to work on the platform we want. We can work on
Absolutely,
Windows,
yeah.
work
You
on
can
Mac,
choose
yeah.
Mac or Windows, and I find sometimes it's actually easier to work on the Mac if I'm sort of working with my iOS applications.
Absolutely, yeah.
Right, rather than trying to do it on Windows. So let's go ahead and look at this, and so you can see here, here's the point where you'd have to do this. This is, by the way, an optional download, and so I would have to go ahead and select the Xamarin Profiler, as well as any other tools I want, like workbooks or the simulator. So let's look at some examples here,
Excellent,
just to kind of
excited.
see how this works. And so I've already got a solution up here in Visual Studio 2017, and this is an iOS app, and what I'm going to do is go ahead and launch this. And we have our Mac sitting over here. This is our build host. So remember, whenever you do Xamarin iOS, you have to have a corresponding Mac to build the application and then to actually run it either in the simulator or with a device. And so I would have to plug my device into the Mac, and then I would also have to use the Mac, I would have to have Xcode installed, and that's how I actually get my simulator.
All right, and we're all set up here with the Xamarin Tools, so we're all ready to go.
Should be all ready to go. So I can see my debuggers coming up.
Perfect.
And then there's my simulator coming up. And so I'm using the remote simulator. So this is a great tool because it's launching the simulator on the build host, but the build host just has to be on the network.
Fantastic.
Right? So I don't actually have to even have it sitting next to me. It could be in a closet somewhere. You know, if you don't like the Apple logo for whatever reason, you can hide it in the corner. You know, you don't have to be ashamed of having your Apple there. And so here is my application. And this is kind of a fun application. It just lets me draw on the screen. And so you can see that I can draw here. And I can even hold down the Alt key and get multi-touch, right, where I can do 2 drawing elements. And then I can hit clear to actually clear the space.
And again, all this is running on the Mac.
All this is running on the Mac, and then we're just remoting the actual experience back over here. And the cool thing is I can even, if I have a touch screen, I can even use a touch screen to interact with this so that it actually is more like a real device, right, which is really, really cool.
So great.
So that's the application itself, and it looks like it runs fine. In fact,
it seemed okay.
Really, it's not bad. I could use this application, and it does work. Everything is fine. However, I want to go ahead and run the profiler just to kind of see, right, how is this application really running?
Because you're going to profile even though you don't have an issue that's obvious.
Right, because I want to kind of know, I want to verify that. I can't tell you how many times I've run into development shops where they just assume that there are no problems because it seems like their app is fine, but when you actually put it under profile, you find there are improvement areas that they could have done, or perhaps even unintentional bugs that are in the app that they didn't spot. And if you run the app long enough, right, then it crashes. And one of the things, you know, with mobile apps and particularly desktop apps is we've got lots of memory available to us and lots of CPU. And so, you know, it may be doing really inefficient things that aren't very noticeable on your high-end device, but somebody runs it on a low-end device, right? Maybe they've got an older iPhone that doesn't have the fast processor that's there. Or maybe they're just not running on a simulator. The simulator on the Mac actually uses the host CPU and the host memory, so it's going to run a lot faster than a physical device anyway. You might not notice the issue there, right? Putting it under a profiler will at least let us identify those issues up front.
Absolutely, fantastic.
So the way that I launch the profiler is I go to the Tools menu, and it's right here, Xamarin Profiler. That will both launch the simulator as well as the profiler tool. Now I'm going to pause here for just a second to point out a couple of things that are here on the screen. So notice that when we launch the profiler, it actually comes up with what it calls available instruments. This is sort of some terminology that was borrowed from the Apple profiler that I referred to.
It's very similar to the one we use on the native tools for iOS.
It does, yeah. And so we sort of, it's kind of, you know, it's a tip of the hat, so to speak, to the Apple terminology that's there. And ultimately what we're really referring to here, and there's 2 different groupings that are here. They are specifically things that we can do to monitor the application's execution.
Okay.
Right? And so you can see the very first one here is all instruments, and that's generally what I pick.
Okay.
But I could also say that I only want to look at memory allocations. I want to analyze the memory usage of the app. I can look specifically for reference cycles. We'll talk about that in just a little bit. I can see memory-related issues. This is similar to allocations. This is just a this is actually a grouping, really, of allocations and cycles.
I see.
So it just sort of combines those 2 elements together.
So it's really just a way of visualizing the data versus an actual different test.
Yeah, correct. I also have performance. So this is another grouping, right? So I could say, I want to analyze the performance of my application. What is it doing with the CPU, and where can I identify places where I potentially could improve my code? And then, of course, we have the time profiler, which is what's included in the performance instrument. So I generally almost always pick all instruments. Notice that I do have my target up here. It says we're going to use my iPhone 7. I'm going to say choose, and it's going to go ahead and launch the profiler as well as the simulator if the simulator wasn't up, and we'll see that the app will actually now launch right here in the simulator.
And again, interacting through the build host.
Correct. And I'm going to go ahead and use the cool little Windows key to kind of slide that over a little bit so we can see both. Now, there's a couple of interesting things that are here in the UI. So notice that we've got a couple of bands running across the top here. We can see allocations, cycles, and time profiler.
Okay.
This is really telling me what are my memory allocations occurring. Cycles we won't really deal with until we stop the profiler, and so we'll look at that in a different app.
Okay.
And then the time profiler, that's my CPU utilization. I can see allocations that are occurring here. You can see I've already had some allocations, and in fact, we can even see over here on the right side of the profiler kind of a little circle pie chart graph that sort of tells me where are my allocations occurring? What are the big ones?
There's really a lot of information here.
There's a lot of information here, and the reality is most of it, while it's pretty, it's not really necessary. There are certain things you probably want to key into to really kind of get a sense of what your application is doing, especially initially when you're starting to analyze the app. So one of the things I'm going to want to watch here is this working set value that's over here. So working set's important.
Okay.
That is, how much memory is my application using at this moment in time? And in a garbage collected system, you'll often see your working set go up and down as your application progresses.
Is this just managed, or is this both the managed and the native memory?
So that's a great question. It actually is kind of a holistic view of the entire application set, but what's really going to go up and down, you have to remember your managed memory is allocated out of the native memory area, right?
Right.
It's all one big block. It's just a matter of who is it that's managing the memory. Is it the native side, where typically I do have some kind of deallocation sort of event, particularly in this app, which is iOS. iOS uses reference counting to be able to hold on to its objects, and so they decrement the reference count, and when it hits 0, they release the object, right? So there's an actual thing that has to happen.
Right, so no garbage collection natively on iOS.
That's
then.
correct,
Yeah.
right? They have what they call automatic reference counting, or ARC. So the compiler takes care of a lot of that. We have similar things with UWP. So in UWP apps,
yes, right.
It's really under the covers. It's a lot of add ref release type of logic that's happening, but the compiler's doing a lot of that work for you so that you don't have to deal with it. So we're going to want to watch this working set, and I'm just going to go ahead and start drawing on here. And you can see that as I draw, I can see my working set go up, right? So now we're sitting at 300 megabytes, right? I can keep drawing here, and I can watch my working set's going to go up and down as we kind of interact with the app. Now, one of the other things that we typically want to do when we're analyzing memory as well is to take what we call snapshots.
Okay.
Snapshots allow us to view the application's memory at a point in time. And typically, I didn't do it this time, but often when I first start profiling an application, the very first thing I will do when the application launches is I will take a snapshot.
Okay, and that's sort of a reference point for comparison later.
That's exactly right. It lets me know what did that application look like initially when we started, so that as I progress through different features, I can kind of compare it and see what was allocated, what was freed in between each one of these snapshots. Right, so we're going to go ahead and keep drawing on here and just sort of watch kind of what happens with this application. Right, and you can see my working set is continuing to go up. We're at 500 megabytes now, 700, 800, right? So, and I'm drawing lots of stuff on here. It's very cool. We're at 1 gig now, so it's kind of progressing up. Right, it is going up.
Pretty high, really.
It is, and I'm going to go ahead and click the snapshot button.
Okay.
Now, when I take a snapshot, what's going to happen here is you're going to see there's a red line that actually gets placed here, right? And so that indicates a snapshot was taken there.
Perfect.
Right? And you can see that it doesn't appear to have affected anything. I still have a fairly large working set as well as my virtual bytes here. I'm going to do just another snapshot. And then I want you to notice what just happened here to my working set.
Well, that's interesting.
Yeah, it just dropped dramatically. So can you think of anything, and you can even see it here in the graph, right? If you look at the graph, right, we can see here we actually had kind of a line moving up in terms of our memory allocation, and suddenly a direct fall here.
Interesting.
Any idea what might have happened there to cause that?
Well, I know we've got some managed memory, so I'm wondering if that's maybe the garbage collector.
Yeah, that's exactly right. So one of the things that happens when you take a snapshot is the system goes ahead and does a GC, right? Because it wants the world, at least in terms of memory, to be stabilized and to make sure to throw away anything that's truly dead, that's gone, that's no longer needed, so that we know exactly what was really part of the snapshot. So we saw a GC. But the interesting thing here is, notice that I had to do 2 GCs to get it to fall off.
That was interesting.
Right? So
I'm a little bit confused by that.
Yeah, so the first GC, right, it didn't seem to affect my working set, although if we look at the lines, it kind of looks like it did. It sort of fell off. But often what you'll see is that working set value doesn't drop until you do the second GC.
Okay.
And there's a couple of different ramifications or reasons for that. One could be that some of these objects may have finalizers on them. So an object that has a finalizer means when a GC happens, it's marked for finalization, some cleanup has to happen, and now the object can now be freed, but it always takes 2 GC passes for that to happen.
And what's that cleanup then, the finalizer?
Could be anything that you put in your code, right?
Okay.
So it typically is, often it's related to native operating system sort of cleanup, so maybe it's a handle to some object that now I need to actually release in some way.
And we would likely have that in our Xamarin World.
Absolutely, yeah. You'll see some of that in the Xamarin World. It's very rare actually to put finalizers in your own code because it's typically used for native operating system managed resource cleanup. But it is possible sometimes, but more often than not, it's for operating system stuff.
Right, and it's possibly the objects that we're allocating from the Xamarin APIs. That
Correct.
Have the finalizers.
Yeah,
so
it
it's
could
not
be.
our finalizers, but it's
Correct.
in the APIs.
Yeah, so I'm going to clear, and we're just going to draw just a little bit more, and I'm going to go ahead and take a couple more snapshots just to kind of get a sense of where are we actually spending our memory here, what's going on with this app.
And we can enjoy your artwork as well.
And we can
so.
enjoy that I do an awesome S, right, because my last name is Smith. I draw S's all the time. All right, so we'll take a couple snapshots, and I'm kind of done now. I'm okay with where we are. I'm going to go ahead and hit stop to stop this application. Notice it went ahead and closed it in the simulator there. We're going to go ahead and maximize this window and just kind of do a little bit of analysis.
Okay.
So
there's a lot going on
There's
here.
a lot going on here, and there's a couple of interesting things that I want to point out. First of all, you can actually select on this timeline. So for instance, I could just say, I want to see the allocations and things that happened right in this time frame. I saw my memory kind of going up. I just want to analyze that. I want to understand what happened in this span, right, where I might do this. I might use this for CPU as well. For instance, if while I was running my app, I saw the app stutter in some way, I might make a note of that in the timeline and then go back after I'm finished and kind of highlight just that area to understand what was happening in the app when I saw it kind of stutter or lock up a little bit. The next thing I'm going to look at is all of the objects that are here. And so there's a couple of interesting things here. First of all, when you look at your full object view, notice that I'm only looking at this range here, and so I can only see, that's why it doesn't look like there's a lot of objects in here, or at least a number of lines. If we just click all by itself, we'll deselect that little section, and now we'll see there's going to be more stuff here. So you can see my scroll bar got a lot smaller. So I can sort this in a variety of ways. I can sort it by size, which is the default, so it's going to show me the stuff that took up the most space. And in managed, or rather in .NET applications, interestingly enough, more often than not, what you'll find is it's going to be strings. Right?
But I didn't see many strings in your application.
No, there aren't that many strings in the application, but you have to remember that strings are immutable in the .NET world. And so anytime we deal with a string, or we concatenate a string, or we work with a string, it actually makes a copy of the string. And so there's a lot of strings that actually get allocated as part of the CLR's running of your process.
But 16,000 strings, is that normal?
That's a lot of strings, and yes, it is actually normal for a lot of apps. And so you will most often see strings being one of the top things in terms of both count and size in your application. And the reality is we really don't care about that, right? What do we care about when we're actually looking for memory things in our app?
Well, I guess probably things take up a lot of space, and I'm seeing even with the 16,000, it's not a lot of size being used.
Right, yeah, it's not a lot of memory that's there. And more often than not, what we really care about is our stuff. Right, so what I really want to look for here in this list are the objects that we create, right? Specifically things that are custom user types that I know I'm using inside this application. And so, the way you can quickly identify that is if you scroll through this list, it's a little bit hard to see because of the dark theme, but we'll see one here. Oh, there was one, I saw it. Notice there are some of these that have a little blue dot on them.
Ah, yes.
The little blue dot over to the far left there actually indicates that this is an object that's part of your application. In other words, it's a custom type created by you that was then allocated as part of your process running.
And I can see that in there, but the name here says Zamdraw View
Yeah, that's
Controller.
right.
So
It kind of gives it away,
It's a good
right?
indication there, absolutely.
Yeah, that's right. And there's only one of them, and that's kind of what I expect, right? So
Perfect,
there was only one view controller that was created for this iOS app, so that makes sense. There's only one. But we can kind of look for these little blue dots to say, okay, these are my objects.
Okay.
If I see unusual patterns with my objects, I'm going to be concerned, and I'm going to start investigating a little bit further.
So the things that we should be responsible for.
That's exactly right.
Okay.
Now, when we look at this here, I'm seeing every object that was created and used during the entire life of the application while it ran.
It seems a little bit overwhelming. There's a lot to go through here.
It is. And in fact, one of the things that we can do to kind of filter this out, if you look over here on my filter box, is there's an only live objects checkbox. When we check that, that will reduce the list to being the things that were alive either within the selected area or within the end of the application running. So what was still alive at the very end? And that's actually what I'm most interested in, right? What's the stuff the garbage collector couldn't get rid of?
Ah, right.
Right? And there's going to be a bunch of stuff in here, actually, that is very common that you'll see in every single app that you profile. So a lot of times the strings don't go away. They're all kind of interned and held in a a different area anyway, and so that's probably okay. You know, most of this stuff is all runtime kind of stuff, weak references and mono methods. These are all things that we really can't affect or do much with anyway. But if we,
they're pretty small as well.
yeah, that's right. They all look kind of small. But if I scroll through this list and I specifically sort it by count or size, either one, I can start scrolling through this and look for unusual patterns.
Okay.
All right. So, for example, as you look through this, is there anything unusual that you see kind of as we just kind of go through this list?
Well, I mean, you threw me off with a string, but I'm seeing UI image. It seems odd to have 147 live images in an application.
Yeah, it is,
especially
isn't
for
it?
a single screen app.
Right. We've got one screen that I'm drawing on, but for some reason we had 147 images that were still alive. In other words, they hadn't been collected for some reason.
So there's a reference to them, then they're being held on by something.
Yeah, they're either being held on to or we didn't clean them up very well.
Okay.
Right? In other words, we just sort of, one of the things that can happen, particularly for things like this, which is an image, these are particularly dangerous, by the way, because an image, if you look at it, like it says we have 147 of them, but it's only 5.7 kilobytes.
Oh, they're little, so it's no big
Yeah,
deal. Not
no
gonna worry
big
about
deal.
that then. Okay, so
Right? But how big, like if you just download, say, a JPEG, for example, and by the way, JPEGs are compressed, but if you download a JPEG, how big is it typically?
could be 100K, could even be larger. Could
Yeah,
be a whole
it could
megabyte.
be.
Yeah.
And so in this case,
So
this
you've
is
got small images.
Yeah, it's a little misleading because what we're seeing here is the size of the managed representation. In other words, what it looks like to the .NET or the Mono runtime in this particular case.
Oh, okay. So there's more memory being held on somewhere else.
Oh, very likely, yes. Because this is just simply a wrapper around some native thing. It's really just a pointer to some bits in our real memory space where the real memory, where the image itself is actually going to be represented.
Oh, so even though we've got a Xamarin UI, piece of a UI image here, that the actual data for the image is not being held in the managed memory.
No, that's right. It's going to be native and it's going to be held elsewhere. And so this is a bad representation because we really don't know how big that image truly is. Right? And so it could be much, much larger than this. And so these are dangerous things to kind of look for. If you see a lot of images and you know your app doesn't use a lot of images or should be getting rid of those images in a more timely fashion, then we'll definitely want to kind of investigate that.
And I guess this tiny size here on the managed side is not enough to put pressure on the garbage collector, so we're not getting the GC to run as often
That's
because
exactly
these
right.
little objects.
Yeah, that's exactly right. Here's another one that I see that's kind of interesting. So I see that we've got 144 CG paths.
Seems unusual as well.
Right, you're an iOS developer. Tell me what a CG path is.
Well, it indicates it's basically indicating where a line would go. It's an end-to-end point, so it'll have an XY coordinate at both ends. So very likely in our applications to do with the drawing.
Yeah, it's representing a path, right? A path from
Yes,
point A to
right,
point
yes.
B. And
Multiple
so,
points,
yeah,
of course,
That's
yes.
right, yeah. So we've actually got a path there. Now, we took a bunch of snapshots, and so we can also go to the snapshot tab here, and I can see all the snapshots that I created. And you can actually see, as part of the snapshot, where the system went up in memory, that's red, and where the system went down in memory. And so we can kind of see how the GC runs. And so remember, we took that first snapshot, and we had actually allocated a bunch from the start of the app.
Right.
We took the second snapshot, and we can see all that memory that we dumped, right, in terms of the objects themselves. If you double-click on a snapshot, you can actually get a sense of what was actually created here. And notice that we have a checkbox here as well, only new objects. If you uncheck this, you'll see everything that was available in the snapshot itself. So
wow.
all the objects that were alive at the point of the snapshot. If you click only new objects, you only see objects that were created within that snapshot period, from the period of the last snapshot to this point.
So not much going on here.
No, and remember, we took these snapshots kind of right after each other, right? We did one and then we did a second one to see it. So this is a bad snapshot to look at. Instead, let's go look at, say, it looks like we kind of went up here. We can look here. And notice that here I'm seeing, again, only new objects, but I see that we have 135 UI images, 131 CG paths, some touches, some colors, some layers, some events, right? So there's a lot of things happening here.
And this is happening when you were drawing with the application.
That's exactly right.
Yeah.
So when we took the snapshot, I was kind of moving, drawing my S's all over the screen. But this is enough information for me to go, I need to look at this a little more closely and see why these were being allocated. So I can double click on one of these images, and what I'll get here is a list of all of the instances of the image itself. In other words, these are all of the instances that were live. And you can see that each one is only 40 bytes in size.
But
right?
again, in the managed memory, not in the native memory.
That's right, but it represents something much, much bigger, most likely. And the cool thing is I can actually either double-click well, actually, I can't double click. I can go over here to my right-hand side, and I can go to the second little button here, which is a stack trace. And this will actually give me the stack trace for the allocation of this object.
That's
so
amazing.
I can look back and say, how did we actually get to this object? And I'm going to skip all of this sort of native stuff that's here and go back to my code. I'm going to look for XAMDraw, and I can see this is actually being allocated as part of drawLine, which was called from touches moved.
In our XAMDraw view controller.
In our XAMDraw view controller, exactly. And so this gives me some information, and then we go investigate my code and try to figure out, okay, why did we allocate all of these images? And why, more importantly, did they not go away?
Right.
Right, because I want to see them go away. So we can do that. Let's go ahead and switch back to our code, and let's open up the XAMDraw view controller, and let's look specifically at drawLine, which is where we saw this problem. So here's drawLine, and you can see inside drawLine that we've got some iOS code here. We get some graphics contents, or context rather. We then are going to render into this context. We create a CG path. We add all of our lines into the path, and then notice we're assigning an image here. Okay, so there's a couple of things that are happening here. First of all, remember that we saw two objects that had a lot of objects in them that were a little suspicious.
We had that UI image and those CG paths.
Yeah, and so one of the things here is the CG path. And one thing to be aware of, at least in terms of Xamarin iOS, is almost every iOS object that you deal with, so anything that starts with two letters, typically CG, UI, you know, those kinds of things, CL, core layer, yeah, all of those are actually disposable. And when we say they're disposable, it means that we can actually tell the runtime that we're finished with this object prior to the garbage collector ever coming in and cleaning it up. Because the garbage collector eventually will clean up this path here.
Well, yeah, they're just local. They'll fall out of scope.
Absolutely, it'll fall out of scope. But when does the garbage collector run, Adrian?
Well, when there's memory pressure.
Yeah, that's right. And it could be, and we actually saw, by the way, as the profiler was running, we got all the way up to a gig, and the garbage collector hadn't really cleaned any of that stuff up yet. So clearly it's allowing a lot of growth in that heap before it does that.
And it's because it's memory pressure in the managed code, managed memory space.
That's exactly right. So one thing we could do here is we can kind of clean this up a little bit by putting a using statement around this path. Right? I can see by looking at this code that really we only use the path up to a certain point. And so I'm just going to go ahead and grab this code here and pull it out and stick it right here. And so now we're going to go ahead and clean up that CG path. Now, when we do this dispose, so using is just a construct in C#, it will call dispose at the end. So when it hits the end of the scope here, it'll automatically call dispose on that object. It doesn't force a garbage collect, okay? I want to be clear on that. It's not actually going to free the memory for the object, but what it will do is it will release the operating system handle that represents the native CG path that we're actually allocating from iOS.
So that non-managed memory is now released, and the iOS operating system can now deal with that and clean that up.
Exactly. When we look at the profiler, that CG path was really small too, right? Our managed representation is just a little tiny wrapper around the handle for iOS.
Right, we're not too worried about that because it's little.
Yeah, we don't care about that. What we care about is what it represents on the other side of the fence, the native side. And so by putting a using, we can go ahead and tell the system, let's clean this up and get rid of that handle and therefore clear it. Now the other thing that we saw was there were a lot of images being allocated. And if I look here, I can see we're assigning an image. Now when we do an assignment like this, you've got to keep in mind that where this is called, because we saw it, this was being called from touches moved, right? So as we draw on the screen,
every time we move our finger,
even the smallest minuscule amount, we're calling that touches moved and we're calling that draw line. So this image is actually being reallocated over and over and over and over and over again.
But again, but we're reassigning it, so we're freeing the old one.
Yeah, you would think. Yes. And the reality is we are releasing our reference.
Yes.
And it does push it back to, to be empty. And so when the garbage collector eventually does run, it will find that and it will clean it up. Because clearly we did it more than 3. How many image objects did we have? 135, I think.
Yes,
something 150, no more than that. We clearly had more images than that, right? So it was cleaning them up. It just wasn't cleaning them up in a timely fashion.
Lagging behind, okay.
Yeah, and so we've got the same problem here because this is a native UI image. Again, this is a native object from iOS that's wrapped with a little wrapper. We want to go ahead and clean these up. And so I'm going to go ahead and say image draw dot image, and it may not be there yet. This might be the first time, so I'm going to use the C#6 null check, and we'll just say dispose. And so we'll go ahead and get rid of the image if it exists.
Right. You want to double check the image property as well, or no?
No, it should be fine.
Okay.
Yeah, that's a real backing store property, so it should always be there as long
Okay.
as we have this image view. Now, if we kind of just scan the code and just sort of look for places where image is being used, I can also see here when we call button clear, we're doing the same thing right here. Notice we're setting it to null to get rid of it, but really all that does is release our reference to it. It doesn't actually release the native reference until the GC kicks in and it finally deletes this object. And so we're going to go ahead and put the same line of code here. Image draw, image question dot dispose, and we'll go ahead and get rid of that image if it was there.
Okay.
Right? So we can go ahead and say let's dispose it.
I do love that C#.
Oh yes, it makes it a lot easier. So before we could use that, before we had the null check, right? We had to say if image is not null, then put this dispose in there. That's actually much nicer.
Nice and concise.
Okay, so let's try this again and let's see if we made any difference. So we'll run this in the profiler. Now, one thing I want to point out, notice that I did rebuild my solution there.
Yes.
You've got to make sure to do that. The profiler doesn't actually build the app for you. If the app's already been built, it doesn't check to see does it need to be rebuilt. And so if you
I've made that mistake before, yes.
if you just run the profiler, you may be running the old build, and therefore you'll get the same exact results and wonder why, because you made changes. Okay, so we've got our app up here. And again, what I'm going to watch for, let's just move this over. Kind of drag this out a little bit. We want to watch that working set. So we're just going to go ahead and draw, right? And I can see my working sets going up, right? 129, 130.
So this is a pretty drastic difference already.
Yeah, notice I'm drawing all over this. And we're really not getting above about 133. Because now we're disposing those objects. We're releasing them from native memory. And so our working set, which represents the whole view of the application, is only going up to a certain point because we're getting rid of those images far more frequently now. Now the GC is not happening, right? We're not kicking in GC.
Our manage objects are still there.
Yeah, the managed objects may still be there. And in fact, if we looked at them, my guess is we probably would see some in here.
Right.
But our working set is more important than that.
Yeah,
That's what we're
it's
really
a
concerned
huge
with.
difference of behavior.
Yeah, that's right. So that's actually a great improvement to this app. And the only way we would have spotted this is by looking at a tool like the Profiler.
Absolutely. And
Right?
I think one thing that's nice to see here is now every application will be different, but what we're seeing is a fairly stable memory footprint. Once the app is up and running, you're using it, you're not seeing drastic changes anymore.
Right, and that's kind of what we want to see. And most .NET applications will run that way. They'll allocate up to a certain point, and then you'll sort of see them stabilize most of the time, and they'll sit around a certain threshold, right? So yeah, we absolutely want to see that. Okay, so let's close this one, and I'm just going to stop. Close that, and I'm going to show you a different application. All right, so let me open up another app here. So this one's a little interesting. This is a Xamarin Forms application. And this application here actually has several different versions in it. So it has an iOS version and an Android version,
Okay.
UWP. And it uses a common component that was written by James Montemagno, a good friend of
yes,
Xamarin University.
absolutely, yes.
And we're using his network connection state.
Ah, fantastic.
Right, and so it's a very, very simple app. I just want to show it to you because I think it's exemplary of common sorts of memory leaks that might happen in your applications. And let's go ahead and close that. And let's go ahead and let's use the Droid version this time, just for
great.
fun.
Because I think a lot of people use this component. It's very
Absolutely,
popular.
yeah. And so this component, if you're not familiar with it, it's this plugin connectivity component here that you can see in my references. We've got it added to our project here, and what this is going to do is use the connectivity state to be able to tell, are we connected to the network or not? So the last thing we want to do is have the user try to do something with our app and have it fail because they've entered into a tunnel or they've had a connectivity issue or maybe they're just down in the dungeon. And
Phone's not working.
Yeah, that's right. Their phone doesn't work, and so we want to provide some kind of experience that says, look, we need to be connected, or maybe provide offline data as a result.
Because we're conscious developers who want to maintain that user experience.
Yeah, that's exactly
really what
right.
we're
Yep,
talking
that's
about here
right.
today.
So let me go ahead and build this first, just to make sure it's all built. So we'll go ahead and rebuild.
Right. Always good to remember.
Always good to remember.
This is nice to see, too, that we can use this on a Xamarin Forms application. So it doesn't have to be just the pure native Xamarin iOS, Xamarin Android.
No, that's right. Well, you've got to keep in mind, Xamarin Forms builds a native app, right?
Of course,
so,
right.
When you use Xamarin Forms, all you're really doing is you're providing an ability to create your UI and your business logic in a cross-platform fashion. But ultimately, at the end of the day, we're still generating native controls. We're still generating native representation. It's a native app for all intents and purposes.
So really, whether we're doing pure Xamarin Android or Xamarin Forms or pure Xamarin iOS, we should still always profile. We should still use the same techniques.
Absolutely. Yeah, absolutely. I don't, there's no reason not to profile your app. And you know, it's funny, while we wait for this to build, there it goes. I'm going to go ahead and launch the profiler here. You know, one of the things I found, particularly with developers, is we often, you know, we get too close to our code. We think we know our code,
Yeah.
and, you know, and we get this idea that, man, I know exactly where my performance issues are. And I'll be honest, just for myself, I mean, I'm often surprised, right? I use the profiler and I'm like, oh, I didn't expect that to be the top function that's being used. So let's pull up the Android emulator here. Kind of expand this out a little bit. Here's our profiler. This is the old version now. Let's close that. And it's going to deploy our app here.
Fantastic. And I love seeing how the tool's integrated with the IDE as well.
Yeah, it's really nice. And again, I'm just going to choose all instruments here. Right, so we'll come in here, we've got the app, it's running. Now the first thing I'm going to do now is I'm going to go ahead and take a memory snapshot. I want to know, what does the app look like at launch, right?
What's set that baseline.
Yeah, what's its current state? And then I'm going to go ahead and start using the app. So we'll say show network status. This is the dumbest app. I apologize for its simplicity. The idea is it shows me a screen, red or green, based upon network state.
Okay.
Right, and it's a separate activity, or rather separate page, not activity, but separate page in Xamarin Forms. So each time I click the button, I'm showing that page.
A really useful, useful app just to see the network connectivity plugin working.
Yeah, that's right. And we could actually go, if you go to the properties for the Android emulator, one of the cool things you can do now is you can actually change the network state. You can change what type of network it's representing and that sort of thing. And so we could actually make it turn red if we really wanted to. But I don't really care about that. What I really want to look at is what is the memory usage. So I'm going to take another memory snapshot here. And I want to compare these two. So I'm going to go ahead and stop the app. And I'm going to go over to my snapshots window here. And I'm going to look at snapshot 1 and just kind of see what all is in my application, like what sorts of things have been allocated. And again, what I want to look for are my objects, things that I know I create. And so one easy way to do that is to use this search box up here. And so I know the name of the app is network state. And so all of my objects that I use all start with network state. And so you can see that as soon as I did that, I have 5 network state problem pages that have been allocated in my app. Now, the problem page is that green screen that we saw.
Right, but you push the back button, that should have kicked up the stack. It should
be
gone.
That's right. That would be my theory, right? But clearly it was not gone. And remember, when we take the snapshot, we do a GC. And so we could force it a couple times if we wanted to just verify those objects are still around. But the reality is this object, for some reason, was still there. Now, you can look at the stack trace to see where this came from. I can see that it came from on next page, and then it kind of went through a couple of things here. But this ultimately came from an on click. So it was us clicking that button.
Okay.
The system then did some stuff, and you can see that there's some native stuff that's here.
It all looks reasonable.
Yeah, this third button is actually can be really useful. It's not in this particular case. We'll see another example in just a second where it is. This is actually a good one to look at. Sometimes it'll have information, sometimes it won't. It's called pass to root. The idea is it will tell me what's holding this object alive. And so if we double click on this, and then pick an object, sometimes you'll get data here. It just depends. Right? The only thing that the profiler can actually pick out is a managed live reference.
Okay.
And in this case, we don't really have one, and so it's not really a managed thing that's kind of holding this alive, or at least we don't think it is based upon what we see here.
But is that seems powerful in itself, and that we know it's not being held live by managed root.
Could
so
be.
It's probably being held live by a native root.
Yeah, it could be. But I can see, that this object is alive. I can see when it was allocated, and I can see how big it is. These are a little bit bigger than they were. And so I'm going to go look at, this is going to give me, again, kind of that moment of, that doesn't feel right. There's something kind of wrong with my app. And so I'm going to go back to my application here, and I'm going to go look at that. So that is my main page. Right, so I know that main page was where we were clicking the button, and here is our on next page that we clicked, and I can see we're just doing a new problem page. So there's nothing intrinsically here that's holding onto that page.
It looks very simple.
It looks very simple. I don't see anything there. So we're going to go look at problem page itself. Now, if I look at this here, I can see that problem page is wiring up to an event. Connectivity changed. And so I'm a little bit interested in that. And one of the things that we could potentially do here is, let's go back to, not all snapshots, come back to allocations. Let's see if we can pick it up off of here. And so we'll do only live objects again. Sometimes that's disabled, and I'm not really sure why, because it shouldn't be. Let's try going here and then here. No, it still doesn't let me do it. So you can see we have the pass to root there as well. And then we, of course, get a stack trace for whatever is here on the stack. But we can do it this way.
Do the search.
Yeah, just do the search. So I'll type in prob, and there's my problem page. Right, and again, I can see, hopefully, all of the allocations that are here. There's the problem page. And it's not giving me any pass to root there either. That's unfortunate. But we can actually kind of get a, from the snapshot, we saw that it was coming from that page. Now the question is kind of what's holding it alive.
Right.
Right. That's really the problem. So one thing that we can also try is go here to this cycles. And so cycles basically looks for places where things are connected.
Okay.
Right. So think like, for instance, object A allocates object B and passes a reference to itself to object B. Right, so A holds on to B, and B now has a reference back to A.
So we're talking about cyclical references.
Yeah, that's
then.
exactly
Okay.
right. It's just it is literally a loop. Now,
Okay.
most of the time, our cyclic references aren't as simple as A and B. It's often A, B, C, D, E,
A
F.
more
and,
complex chain.
Everything's all connected together, and so
When children have
it's a little bit
references
harder to
parents
find.
and things like that, right?
Yeah, that's right. So we're going to look here and see if we can spot anything. So it's still detecting cycles. So it's got some stuff in here that I can see that it thinks might be cycles. And we can kind of look through this and sort of see, is there anything in here that maybe looks like what we're kind of looking for, our problem page in this particular case. And so you kind of have to spend a little bit of time and sort of walk through some of this and see if you can find anything. So let's see. We got there's a bunch of functions here.
So what I'm getting from here is that the profiler, it's an incredibly powerful tool, but it's not just a run and have it discover all your problems.
No, that's right. You have to kind of explore a bit and sort of look at it. But notice one thing that I do see a lot of here is there's a lot of delegates in here, right? A lot of these things are represented by delegates. You see all this create delegate sort of language
in the
that's
stack
here.
trace, yes.
Yeah, there's a lot of delegates that are in here. And even though I'm not seeing exactly what I was looking for in this particular, because there's just so many in here, I didn't expect quite that many to show up. But one of the things that I think is really useful is to see that it is a set of delegates, and that means that we probably want to look at maybe where we might be using a delegate. And in fact, we do see there is a delegate being used here where we're connecting up to the connectivity changed. And this is one of those areas that is very, very common in .NET.
Those .NET memory leaks we talked about.
That's exactly right. We've got a delegate that's holding on to our type. And you have to remember, when we actually wire up to an instance method on a delegate, like this here on connection changed,
Yeah.
it means that it has to hold on to a reference of the owning type problem page, right? And so the delegate holds on to that. And if we went and looked at cross connectivity, I can almost guarantee that there is a global static that's holding on to that.
I think it's a static property, is it not?
It is. It's a static
current,
property.
Yeah.
That's right. So this is a static property with an event on it that's holding on to this instance method.
Right, so it's never going away.
No, that's right. If a static's holding on to your type, it's never going away. So how do we fix it, Adrian?
Well, I think we need to unsubscribe.
We need to unsubscribe. And this is generally good advice. Anytime you wire up to a delegate, you should always unsubscribe from those delegates. So I'm going to change this code just a little bit to, instead of actually wiring it up in the constructor, I'm going to use onAppearing. So this is a method that's called when your app first starts up, or when the page first starts up, rather. And there's a corresponding method called on.
Disappearing.
Can you guess? Disappearing. Right, you're so smart. That's why they pay you the big bucks as a trainer. And so we're going to go ahead and do a minus equal on that. Now, when we do this, we're now unsubscribing. So when the page appears, we subscribe to the event. When the page disappears, we unsubscribe from the event. Let's build it and let's try it one more time.
And this can even be sometimes not even just a memory issue, but a performance issue as well. If you're doing some work in these methods, you're holding on to them. Now you're calling all of the subscribe methods.
Yeah, that's exactly right. All right, so let's run the profiler one more time and just see if we've fixed this problem. So this is our second problem, right? We can use the profiler to identify performance issues in our app, memory or CPU, or we can use the profiler to actually identify memory leaks like we're seeing here. Right, so the app's going to start. It's going to launch in the network, the emulator here. I'm going to go ahead and take my snapshot, say show network status. right? Go back, show network status, go back, take another snapshot just to see what's happening. And by the way, I can actually look at this even live, right? So notice that I can come here and I can say only new objects. I can look through here and say the app is still running, right? I'm going to look for problem page. There are 2 of them, right? So let's do one more snapshot. Let's go back and look at snapshot 3, right? Or even go to the allocations page and say only live objects, right? We can do it here too, right? And so notice now we only have 1 object.
Much better.
Right? We've clicked it 3 times, we know, but now we're seeing it get cleaned up. Now, why do we still have 1? That doesn't make any sense. Why? Any ideas?
Oh, this is the problem page.
Because GC hasn't run.
Right, it hasn't been collected yet, so it's
GC's
silly.
not
Okay.
deterministic. We don't know when it's going to run, right? Now, if I again take another snapshot, right, and let it go, probably I would expect maybe that to go away, unless actually we were potentially on the screen.
Make sure we're on that page.
I thought I might actually be on it. I'm not sure. So yeah, do one more snapshot and let's just see. It looks like there's still one there. So if we close this, right, so app stops. Let's kind of get rid of our filter there and say problem. Yeah, it looks like we still had 1 at the very end for whatever reason.
But 1 is much better than 5 or 6,
Yeah, that's
or
exactly
as
right.
many times as we navigate through.
Yeah, that's exactly right.
Yeah.
So we can see that it did actually kind of do what we expected to do, which is great. So the profiler is a great tool. It'll help us to analyze and identify potential issues in our code before we release it to our customers and where they have problems, particularly on lower end devices. So we definitely want to take advantage of that.
Absolutely, and I think the things you showed us here today are problems that, as the apps are used longer, they're going to be causing bigger problems. Or again, especially with the first issue, you're on lower power devices with less memory, that could actually be causing problems or at least performance bottlenecks.
Absolutely. And if you want to learn more, we actually have some great content
Absolutely.
in Xamarin University. So what I've talked about here is actually part of a course that we deliver in Xamarin University,
Right.
where we go into far more depth about the sorts of issues you can encounter and the things that you can identify with the profiler.
Yeah, we have a whole series of advanced C# courses and a course on memory and performance issues as well. So
Absolutely. In fact, we have courses on asynchronous execution. We have courses on F#. We have courses on basics of C#. If you're not familiar with some of the common things that you use in C#, you can go check out Xamarin University, look at the self-guided content that'll kind of get you started with mobile apps, and then sign up to be a subscriber and become a mobile certified developer.
absolutely.
Awesome. Well, thank you so much for attending this session. It's been a real pleasure to kind of hang out with Adrian and show you a little bit about how the profiler
Yeah, thank you.
works.
I learned a ton today.
Yeah, this has been great. Thanks so much for hanging out. And again, if you have questions, make sure to ask them. You can go to the forums. You can go to Stack Overflow. We've got people that sit in those places and we'll be able to answer all of your questions.